Here we're given the letters D, G, I, and T, and we're asked how many 5-letter strings can you form with those letters. So it's a permutations question, and since the I appears twice, we know it's a permutation question with a repeating letter, and we know how to handle that. But then there's a second step in this problem. There's a restriction, and you'll often see a restriction in a counting problem. Make things a little more difficult. And what's the restriction? You cannot have two I's next to each other. Well, the way we're going to handle this is make it a two-step process. I'll write 1 and 2. First, we're going to pretend that there's no restriction. So the first letter we'll write could be any one of 5, and then 4, 3, 2, 1. So that would give you 20 times 3 is 60, times 2 is 120. Permutations divided by 2, because we don't want to double count anything. So I divide by 2, and I have 60 permutations without any restrictions. But now we look at the restriction. You can't have two I's next to each other. So how do you deal with that? Well, this one you have to be pretty clever, and this is not an easy question, in my opinion. What you could do is treat the I's as if they are just one unit. It's just one letter. And then, of course, each of the other letters as if they are one unit. And so now we are asking, in how many ways can you arrange those 4 units? So 4 times 3 times 2 times 1 is 24. We are then going to take the initial 60 permutations and subtract the 24 that would violate the rule that you can't have two I's next to each other. And 60 minus 24, that's 36. And so that's our answer, 36. And that approach is pretty clever. Now, another way to handle it, and the way that most people would handle it, is to do what? Create different scenarios. What do I mean? Well, let's create our 5-letter slots here and create scenarios in which the I's are separated by at least one slot, maybe more. So scenario number 1, I is in the first slot, in the third slot. Okay, scenario number 2, I is in the first slot and not the third but the fourth. And then scenario number 3, I is first and fifth. All right, now let's add a few more here. So we started off with I in the first slot. How about I in the second slot? Well, then you could have I space I, or you could have, again, if I is second, you could then put I fifth. And one other possibility, one other scenario, I is third and I is fifth. So we have 6 scenarios. We've taken care of the I's. Now what about the other 3 letters? Well, now we're back to an ordinary permutations question. Let's look at scenario 1. This first empty spot could have been D, G, or T. Could have been any one of the 3 letters, which means the 4th slot would have been any one of the remaining 2. 5th slot, the last letter. So we have 3 times 2 times 1. We have 6 possible permutations in this one scenario. And then how about scenario 2? Same idea. 3 times 2 times 1. 6 possible permutations, etc., etc., etc. And we have what? Have I written down all of those? Yes. So we're going to be adding each of those numbers. The result, again, 36. First approach, some think to do this, some don't. Second approach, probably more people think to do it this way. Both of them absolutely fine. Answer to this question, 36.